Veronica. I'm joined by my colleague Jaime, and we're with Ocean Protocol. Today, I'm going to show you how to submit to the Predict ETH Round 4 competition, and we'll even do a quick little tutorial at the end for how to use some technical indicators to predict the price of Ether. I am going to start by sharing my screen. So let me go ahead and share that now. Okay, you should see an infinite mirror, and here we go. So right now I have pulled up the Ocean Protocol GitHub Predict ETH repository, and in this repository you can see the main page has the current challenge, and we are in round 4. So this is the 4th Predict ETH challenge that we've hosted. The deadline for this challenge is April 5th. And it ends at midnight UTC, so 11:59 p.m. Universal Time Coordinated on April 5th. That is pretty close. You have about a little over a week now. So let's click on the current challenge, and then you will see the announcement here is a blog post, but the challenge here is the actual README for the challenge. So we'll go through this. So we kicked off on March 3rd. Deadline is April 5th, again at midnight UTC. The 12 hours of predicted Ether prices need to be starting at 1 o'clock Universal Time Coordinated on April 6th. So the contest ends at 11:59 UTC midnight on April 5th. The next hour through 12 p.m. the next day, you need one prediction per hour to be able to predict the price of Ether as accurately as possible. Now, in this competition, the top 3 winners have the lowest prediction errors. That's it. We are not giving extra points for example, your feedback or presentation. We are just doing who has the most accurate algorithm, and we believe that this is the most meritocratic way to evaluate submissions. Also, we have had a lot more participants, so because of that, we needed to find a way to make it more fair and more manageable too for us to judge so many submissions. And so for that, we will calculate the normalized mean squared error. So what does that mean? Well, I will go through a little bit in a few seconds here, the NMSE that is calculated by the judges. But first, there are some criteria just to be eligible to win. So you need to complete these 6 items. First, you need to sign up to the Decites platform and register for the competition. I will show you how to go ahead and do that. You're going to need to create an Ocean Data NFT and set the values correctly. The label, the number of predictions needs to be correct, and then the correct formatting for your prediction values, encrypted with the judge's public key. So that data NFT that you create will be encrypted with the judge's public key, and that will contain the predictions for the next 12 hours of Ether. Then you need to transfer that data NFT to the judges before midnight UTC, April 5th. And the transaction of that, the transaction ID of that transfer needs to be sent to the Decites platform so that we can keep track of the submissions. Everything is occurring on Mumbai's Polygon test network, not on another network. And what we changed from the last competition is no need for a presentation anymore, or how well you followed the flow. Either you're eligible or you're not. And then feedback, you can always give us feedback. Here is the form to provide feedback. It's on the README. Of course, you can anonymously provide feedback to us about what we can improve, and we're always looking for ways to improve. So let's talk about Decites real quick. Decites is a competition platform that Ocean Protocol supports. So I'm going to decites.ai, and here you'll be able to find a connect wallet button. Once you connect your wallet, you should be, well, actually first, you may have to register on their Discord for the profile to be created. So let me show you their Discord, and I will drop the link in the chat so that you guys can go ahead and join. So let me copy the invite link and first put that in our chat. So hopefully you can still see my screen. I'm going to paste into the chat here. This is the Decites server. So you should join this server. And once you do that on the server, and you should still be able to see my screen, you go to authenticate your user account. So there is a bot that can show, cool, Zaraki actually just did this. I think maybe you just did this now. So congratulations. So you go into the server, and once you create an account here, the owner of Decites server goes by Innopreneur. His name is also Manon. He is going to provide the development support that you need, any developer support you need for the competition. Once you work with this platform, you'll have like a direct contact throughout the competition to debug any submission issues that you may have. So Decites is really active. Manon is really active on their server. He is usually up right before the competition deadline, helping people submit. So know that you have a resource there. Really, really good resource. So that is the Decites server. You can see the Ocean Data Challenges channel here and how to submit to the challenge. So if we click here, and we've got this form, this is Decites documentation. Let me go ahead and drop this link as well into the chat. So this is the information you need, your Decites profile ID. You can find that using the link on the form, the challenge that you're using this for. And Jaime, if I can ping you for a second. Here, let me open up my Discord again.
Yes.
Yes. Is it correct that Manon is the best point of contact on Decites? And if so, am I pointing everyone in the correct direction for this form? Because I believe this is still the flow after the DEX challenge.
I think it's correct, yeah.
Yeah, so we just had a challenge, and so let me give you, sorry for my disorganization here. Let me jump in here. You may be able to see my MetaMask, so I'm going to stop sharing my screen for 1 second and then log in. Hang tight, guys. Let me log into my MetaMask. Not that there's like really anything to hide too much, but I think it's good practice not to show the wallet when possible. So I'm signing in to decites.ai. And let's see here. Okay, so once you're in, and let me share my screen again.
Oh, yeah, okay.
Yep. Go live. Okay, so I'm in Decites, and this is what it looks like when you're inside Decites. So we were at decites.ai, and when you navigate there and you connect your wallet, you get to this page here, in review, accepted, rejected, my submissions, my organizations, challenges. Let's click on challenges, and then you will see the challenges that are hosted onto sites. You've got Predict ETH round 4 and the information here. Here is the README link. Again, there's like some redundancy built into where you can find it because it is important. And then recall that the first thing is signing up for the Decides platform and registering for the competition. So that is all done through the Decides Discord that I sent you guys. You should ping Innopreneur, otherwise known as Manon, to create your profile, and then you will have a profile ID and everything that you need to submit. So when you click submit your proposal, this is the link that you get. It's a challenge submission form. So let's talk about creating the Ocean Data NFT, because I think that I covered this pretty clearly. Let me put to sites.ai link here as well. So I'm going to copy and paste that into our Discord chat just so that everyone can find it correctly. So you've got the Discord link for Decides, you've got the challenge page for Decides, and once you create a profile and connect with your wallet, you'll be able to access everything that I just showed you. So back to the README, which is here. Okay, now we can move on to, yes, and here are the steps. Actually, I should have scrolled down before showing you all of that. So basically, the README that is for the competition, and I will put that into our Discord chat as well, covers everything you need to submit your profile to Decides. So here's the README competition, README. Okay, great. So here is the steps for Decides, right? Now to install Ocean, you would just pip install predict-eth. You would do this in Git Bash or your terminal if you're on Mac or a Linux machine, and then pip install these libraries: ccxt, ETH account, matplotlib, numpy, pandas, profit, request, and scikit-learn. And this is important because when you do the competition submission, you're actually going to use some of these packages. Like, for example, what the judges will do is they'll use ccxt feed from Binance and get the open, high, low, close values for Ether for the hourly predictions to compare your predictions. So you may, if you want, use the price feed from ccxt Binance to make your Ether predictions, and that will more accurately match what the judges use. Now, you're welcome to use whatever price feed that you want. Maybe you find that Ether prices are influenced by Bitcoin prices or a sentiment analysis, whatever it is that you want. But I know that what I did in the last competition is I used ccxt Binance feed to kind of match my predictions closer to what the judges were going to use to judge. So what the judges will do is at the very end of the README. So you pip install these libraries, and then we are going to do the remote setup for OceanPi. So the remote setup is super simple. You click on that README, and what you're going to do is you are going to open up the Python console in your terminal. If you have installed ETH Brownie before, great. You don't have to run this line. If you don't have that installed, then you need to run this line of code because there is a network config YAML file that you will have to edit. For the most part, everyone is going to skip all of this because when you pip install predict ETH, you actually installed OceanLib, and so you can just scroll down to here. So here you can create 2 accounts, and you can get fake Ocean on Mumbai and fake Matic on Mumbai for both accounts. You export the private keys that are created in this step when you run this step in your Python console. And once you do that, you can actually copy and paste this chunk of code that asserts that there's enough Matic and Ocean for each account. So why are we doing that? Well, it's because you need to make sure that you're running in Mumbai and that you have enough gas to be able to, or funds to be able to pay for the gas for transferring your data NFT. Then you can go through the main flow README if you want. You can get, oh, this is, excuse me, not main flow README. This is the main predict ETH README. And you can actually get some Ether price data from these sources here under example data sources. So hang with me here because I know it might seem a little complicated. If you have any questions, Ocean Protocols Discord and Decides Discord are here to walk you through everything. So definitely reach out to us if you get stuck or confused. But when I did the competition last time, I found this to be, even though it's kind of like a long README, I found it to be pretty straightforward and I didn't have any issues submitting. So if I can do it, I feel like you guys can too, because I am kind of like not a super savvy smart contract developer or you know, someone who's like so familiar with Web3. I myself work in marketing, so if I can do it, definitely I think that you guys can do it. So then we scroll down to this portion where you build your AI model and you make your Ether price predictions. What we do in this README is just generate some random numbers as your price predictions. So that you can, just as a proof of concept, follow this README. And when you follow this README, you can calculate normalized mean squared error for your prediction to kind of see how you're doing. So this is not a required step, right? These two, everything from the random numbers down to calculating NMSE are not necessary for you, but you can go ahead and do those if, especially calculating NMSE, if it helps you have confidence in your price predictions. Okay, but the important thing for you guys is publishing and sharing your predictions via Python. So in your Python console, where you got the Matic, you got the Ocean, for your accounts. So account number 1 that we created in remote setup README. So remote setup README was here. And we created 2 accounts, account 1 and account 2 in this step. Let's call account 1 Alice and account 2 Bob. And Alice and Bob accounts, like we call them here, Alice and Bob. So in the predict ETH steps, actually the first line, data NFT equals ocean.data NFT factory, create from Alice, data NFT1, DN1. So this is going to use Alice first to create the data NFT, and then Alice is going to give the, well, first you're going to encrypt the predictions with the judge's public key, which is provided here. And then you are going to store your predictions in the data NFT and then transfer it to the judges. So Alice is account 1. You don't need the account for Bob technically. When you just copy and paste those code chunks from remote setup, when you do this flow, you can just ignore the code chunks for account 2, right? Account 2. So Alice is all you need, and then you'll continue on to this line here. Well, first you're going to store your predictions, right? You are going to cast to a string your predictions, and then that string is going to store in this variable prediction value string, and then you're going to asymmetrically encrypt that string with the judge's public key. Okay. Again, all in Python. If you want, or you don't really like Python, understanding every line, not to worry, you can just copy and paste from the top right corner this into your Python console. So that should do everything automagically for you guys. So the last step of this, so it goes to the judge's address, which is provided here. And after everything is said and done, you have the transaction ID of the transfer of the NFT printed to the console. You're going to take that transaction ID and you're going to put it into the Decites platform. You're going to copy and paste it to the field in the Decites form that has that transaction ID field. And then you'll get a message confirming your submission. So double check that you submitted everything. After that's said and done, you have submitted to the challenge. And again, for your reference, what the judges will do after you submit is all provided here. And you can see that they're using Binance's price feed for Ether on the hour, and they're calculating the normalized mean squared error of the difference between the actual values from the centralized Binance exchange to your predicted values. And then the difference between that is going to dictate the normalized mean squared error. You want that error to be as close to 0 as possible. Does anyone have any questions? Did I go through too quickly through some parts? Is there anything that's not clear from what I discussed so far? I don't see any questions yet. So again, let me point you to the dev support channel in Decites. It's dev-support. Remember, you first go to invitees, and then Innopreneur will invite you to the Decites platform. And then any questions that you have, you go to dev-support, especially at the end of the competition if you have any questions about submitting. Oftentimes people do submit close to the end of the challenge just because your predictions backtest or the predictions that depend on the historical data may be most accurate if you wait to the end of the competition when you have the latest data for Ether prices. So that is Decites dev-support channel. And then also you have at your as one of your resources the Ocean Protocol Data Challenges channel. You also can go to general chat and ask, but we will likely redirect you to data challenges. So if you have any technical issues using Ocean, you can go here, tech-issues, but it may be slower toward the competition deadline to be able to access this for help. I recommend first the dev-support in Decites, and then going to Ocean Data Challenges. And then after that, after Ocean Data Challenges, if you don't get support, and you can see Manon is very active here as well, if you still don't get the support you need, you can go to tech issues, but in that order is what I recommend. So in the chat here, I am going to paste the order. So first, get support on Decites Discord. Oops, Discord. Then sessions. data challenges. Let's see. Protocol Discord issues. Okay, so that is all the useful information that I can give you. Definitely this, and you should still be able to see my screen. I know that there's this like infinite mirror here, but if you see the chat here, then you should first go to this competition README, follow the steps here. It will take you first to the Decites AI website. After you set up your account on Discord, you'll be able to see with your connected wallet profile the competition, and then this is the link to the challenge, the data challenge, the data competition. And then after that, you should use your AI model to generate predictions and go back to this README and follow the steps. Sound good, guys? I'm going to assume if we don't have any questions that everything is clear. Feel free to raise your hand, put something in the chat, or direct message me as well if you are still confused or you're feeling shy. Right now, I want to pass it to Jaime if you guys don't have anything else for me. Again, we'll open up questions like a Q&A session at the end. So feel free to hang on to your questions till the end.
Okay, thank you so much, Veronica. So what I'm gonna do is quickly go through an example of how to do an algorithm that predicts the price of Ether for the next hour, and it does it in a way that allows you to test your algorithm with a good portion of the data that we have for training. At the same time, this is going to involve using the price, that is what you will find in most of the samples, but also using indicators or transformations made over the values of the price of Ether. So let me share my screen. Can you see this?
Yes, yep.
Okay. So the first thing is from where to get the prices. So Veronica was showing that in the README you have examples of how to get data from CCXT, and also there are examples in the repository for getting the data directly from Binance or from Ocean. In this example, I'm getting the data from Yahoo Finance, right? And there is a library in Python that is called YFinance that allows you to get this data directly. So this is what I'm using here. The reason why is because it's very convenient, because it allows you to get data from the beginning of the time that Ether was trading, in some cases with a single call, depending on what is the granularity of the data that you need. For this example, what we are going to do first is to define what is the ticker. Remember that this is coming from Yahoo Finance, so you have all kind of assets in there that are in the stock market, but you also have Ethereum and Bitcoin. So this is the ticker for Ethereum, ETH USD. We can ask the library to give us the historical prices with a particular interval and for a period of n days or months or years. For the sake of the sample and to make this run live without burning my computer, I'm just gonna use 180 days of data, an interval of 1 hour that is similar to what we have in the competition. This data is gonna come with information about dividends and stock splits that are normal in the stock market. But in the case of Ethereum, we don't care about this information. There are no dividends paid. And there is definitely no stock splits properly defined. So let me just run this cell. Then we will see the data that we are getting is a data frame. So we have the open price, the high price, the higher price for every candle of 1 hour. What is the lowest, the close, and also we have volume. So this is the initial data that we get. And most of the samples that you will find in the repository are based on only those values. Most of the time it's just the close value. But let's try to use all the information that we have. So this is the first 5 variables that we will start. And then let's go for some simple moving average. In this case, and for the sake of this example, getting the moving average, but selecting 3 different windows. What we are doing here is basically we make a window of a particular length. Let's say in the sample of 10 is 10 candles, right? We average over that 10 values. This became our current value, and then we move the window 1 candle. So now we have 9 of the previous values plus 1 new. Then we get the mean, and then we continue doing this until we arrive to the end of the data. The same process is done for 30 and 60 candles. So we are looking more into the past for each one of those. And we are going to be adding this as a new feature in our data frame. So we have a moving average for a window of 10, 30, and 60. Another very common indicator used in trading bots and people trying to predict the change of prices is the RSI indicator. So this indicator that is showing the strength of the assets regarding how many days or how many periods of profit or loss has been seen in a previous window. Normally, the size of that window is 14. So what you are doing is you look 14 time points in the past, right? 14 periods, and from these 14 periods, you calculate how many of those there was profit, and then you average what was the profit in which one of those where there was profit, and you do the same for when there was loss, and there is an equation that basically made this number to be between 0 and 100. Usually when the value is about 70, it's a good indicator that the asset or the stock is overbought. Then you want to sell, right? But when the value is too low, that means that it's oversold, and the indicator is indicating you that probably you should buy and expect a change on this. So let's use this also as another feature. To do this, I'm using the library that is called TA, Technical Analysis. There are many libraries. I just choose this for example because it's easy to use, right? So the momentum that we are going to use is the RSI indicator, and this is one more of our features right now. So we have now in combination with the value and volume, 9 features. Let's add another indicator. In this case, we are going to go for the Bollinger Bands. So we will have 3 values. This is going to give me the envelope, like the top, the upper band, the mean, the medium band, and the lower band. This is another indicator that is usually that you will find usually in trading bots as one of the many indicators that people use to try to determine what will be given a particular information from the past, whether you expect a positive trend or a negative trend. Now, adding this to the data is going to leave us with more than 12 features, right? It's still a small number of features for a strong machine learning algorithm, but take into consideration that now you can go and use the same in any other asset that you want to add to this algorithm. So let's assume that you want to include Bitcoin information into the model that predicts Ether. And why would you like to do that? Because movements on Bitcoin repercute in the price of Ether, and there is a high correlation between the two assets. So you may actually get some extra information by looking at the prices of Bitcoin and use that information to predict. And you will go and repeat the same procedure that we have here for each asset that you consider or that you find that is correlated with the price of Ether. Do you have any question until this point? Okay, so now that we have this, let's define what is going to be our data, what are the inputs, and what are the targets. So what we want is the price of the next hour. So let's use the close value, the value, the value of the last trade made in a particular period of 1 hour, as this is the price that we want to know. And of course, for the current hour, I know what was the close price, but I want to know what is going to be the close price in the next hour, because in the training data we already have all this data, all this information. The only thing that I'm doing is shifting the value of close to say this is what we want to predict. Basically, I'm bringing the data from the future 1 hour to the past and say, well, with all the information that I have now, I want to predict what is the close value that was 1 hour after. And this is what I'm doing here by adding this column Y. It's going to be our target. Then this is going to produce one input in the data that have a known value, right? Because you are moving things from the future to the past, but when you arrive to the more current value, you don't have anything to bring from the future, so there will be a NaN value. So with this line, I'm just removing any NaN values that may have appeared, either because of this shift, but also because what we are doing here in the rolling window. Because when you start rolling the first window, right, you have 10 values that will disappear. And instead of just putting the data frame, they will be filled with NaNs. So we remove all these values. The maximum amount of data that we are going to lose is 60 hours on this. And we have now what is going to be our labels, Y and X, or data. Notice that I'm removing the value of the labels, or the value that we want to predict, from the actual data that we are going to use as input. Now let me just run this to have this complete, right? So now we have X and Y fully determined. Now, how we are going to do this? What I'm going to do is that I'm going to define a portion of the data that we downloaded as this is the training, and another small portion is going to be the test. In this case, using approximately 170 days, as is actually a bit less than that, as the minimum amount of data to train. I'm saying minimum because we will start there, 170 days. So we go back to the past, 180, and then from that point forward, we select 170 days. So basically, it's 10 days from in the past from today, right? And this is the limit for the training set. And the last 10 days, in average, will be what we are going to try to predict hour by hour. How do we do this? So we have a window of 170 days. We use that data for training, and we predict the next hour. Once that we have predicted the next hour, then we select 120 days plus 1 hour. We retrain the algorithm and predict the next hour. And then we do this until we arrive to the present. But you see in this case is that when you are predicting a particular hour, you don't have that value in the training set, because otherwise it will be an unfair comparison. Then this is what this part of the code is doing. We are selecting the data from the beginning, 180 days in the past, to this current point N that is starting here in this value. Is the minimum amount for the training set. We do the same for the labels, right? Now, the test sample, the test features are the value now. Notice that this is selecting data from the beginning to now minus 1 hour, right? And this is the current hour. This is what we are going to use for test. And then we want to go, we don't know what will be the value. We just know the inputs that are coming from the inputs that are basically the previous values for Ether. And from Y, we get the current value that we actually were marking it as this is the value in 1 hour. So this is what we want to predict with the current values for the input data. The input data is all the indicators that we have plus the values 1 hour ago. So we had divided our data in training and test for this particular window that comes from 108 for 180 and 70 days. The next step is you can skip this or not, but having the data standardized is going to help you to obtain a better model in terms of the optimization. If you have the data have different levels of magnitude, the optimizer will take more time trying to find something that really fits. Probably in a linear model, this is not something that will affect too much the response. But if you start having more elaborated models, standardization is a good thing to do. But we need to standardize this in a way that is fair. So what we do is that we extract parameters from the trained set, and we apply those to the test set. If you were to apply the scaling factors using all the data that you have, then you are already including information from the future in your training set, which is unfair. So your results are just going to be optimistic. Once that we have normalized these two, the training and the test set accordingly, then we can proceed to fit models. Let's start with a simple, with an ordinary least square, the linear regression, right? This model is coming from Skylearn. It's already available. And this made the things easy for us. The only thing that we need to do is to define what is the model and then fit the model with the data that we have for training. Once that the model is fit, then we can use this model that we train to make predictions, right? So we fit with the training set and we test with the test sample that we have. And what I'm doing here is just saving all the predicted values in a list, so that later we can use this to compare whether we did well or not with respect to the real values. In the same line, let's train a different regression model that is basically a linear regression, but this time have a regularization parameter. The regularization parameter is basically penalizing the model from having weights that are too big. Why you would like to do this? Because it's common in linear regression that if you have any variables, the algorithm just end up giving massive values to some variables, basically to try to fit the noise. And this is something that you don't want. You want the system to generalize, to learn beyond the training. So lasso is one of those methods that allows you to penalize the model for overfitting, right? And it's actually finding an explanation for the data that consists of few variables. There is a parameter for lasso that needs to be known. It's called alpha. But it's impossible to calculate this in a deterministic way. So you need to try many variables, many values for this, and see which one does better. But of course, you need to do this in a proper way. This method, Lasso CV, is doing cross-validation to find what is the optimal alpha. So that's why I am running this only the first time when we are training with all this data. And then after, I just use the value that we found for the most of the data that is in the training set. So I'm saving alpha at the beginning, and then alpha is being used in the subsequent windows. And finally, I'm just creating a vector that have the actual values, right, that were used for testing. When this is run, and we use the two values, the actual values in the for testing and the values that we predict to calculate the MAA error. So this is is giving us the average absolute error observed in the data. What this means is just telling you if the value is, let's say, 100, it means that in average your model was $100 off of the actual price of Ether. And if this is the case, this is just telling you what is the magnitude of the error, but it could be that sometimes was $100 up and some other times was $100 below the actual price. And then of course 100 is just the average, right? Telling you in average what was the error in some samples may be lower or higher. So let's just plot this, run and plot these results just to see whether Lasso or the standard linear regression is doing better. This is gonna take a few seconds to run. Let me try here. So we have 168 hours used for testing, and we are predicting in each one of these hours how the algorithm is doing predicting the price. So this is the result. What you see here is that the error is actually low. So in average, the algorithm is deviating from the actual value of Ether by $7, 7.75 in the case of linear regression, and 7.50 in the case of Lasso. The difference here looks massive, but it's just because of the scale in the wild level. It's just to make it clear. Now, this is dummy data. It's not enough data to have something that will produce good results, but it still is giving us an error that is low. If you were to use something like profits for this type of data, you will definitely have an error that is higher. And the reason is that the models like Profit are assuming that there is a long-term pattern in the data that should be discovered, and it tries to fit that. So it's trying to fit that there are seasonalities which may or may not exist in the data, but the seasonalities, if you are trying to predict the price in 1 hour, it's likely that the seasonalities of things that were happening month by month is not going to help you to make a better estimation. Another thing is that it's also modeling the trend. And if you were to look at the price of Ether from the beginning to now, it will seem that the trend is just positive. Despite the value going up or down, the global trend is a positive trend, which is gonna basically tell you should buy. But in the day-to-day, this is not the case. The trend doesn't remain in a single direction. So that's why this is concentrated in values that are not beyond a few months in the past. The final message with respect to the two algorithms is that as you include more variables in your model, linear regression will have a tendency to do worse, not better, unless you find a way to compensate for overfitting. And one of those methods is last one. That's why I'm showing it here. This is gonna try to find what are the actual more relevant features without you doing directly feature selection. And the way that does is that end up multiplying by 0 features that actually don't contain significant information to improve the results. And this is all about this example. Let me know if you have any questions.
Does anyone have any questions, even including how to improve your algorithm? Jaime is an expert in all things predictive trading, and if you guys are curious about how to improve your models, now is a great time to ask. Okay, well, if there aren't any questions, and again, feel free to DM us or to reach out to us on general chat, or the data challenges channel is even better if it's challenge related. Please follow us on Discord, and Hannity here is also here to support with any questions that you have. So thank you, Sadaki and Beluga Whale, for joining, and I'm excited to see how your competition submission goes if the NMSE is really low. And happy trading, happy machine learning predictive predictions.
Thank you so much, guys, for your attention.
Bye. Thank you.
Bye bye.